This should be a relatively short video on variation. Variation is a fairly simple idea. When you think of the word variation, something that comes along with that, or three different words that come along with that are direct, inverse, and joint, or something varies directly with, or inversely as, or jointly as. So we'll look at each of those in sequence here. So direct variation, if a thing is said to vary directly with another thing, what does that mean? Well, all it means is that as one thing gets bigger, so does the other one, or as one thing gets smaller, so does the other one. And this is what we see when we see direct variation. We see y varies directly as x, okay? And this k is what's known as a constant of variation. It's the rate at which they vary with each other. If it's direct, if it's inverse, if it's jointly, there will always be a k in any kind of variation problem. And I just want you to think about this too, because if this form of an equation should look familiar to you. In fact, and pretend the k was just an m, right? That'd be y equals mx plus b, where b is 0. So we'd have some kind of graph. Maybe it would look like this, depending on what k was. Now think about this. If you're plugging in an x value that's bigger, you're going to get an x value that's bigger out. If you're plugging in a y value that's smaller, you're going to get a y value that's smaller. So it varies directly. It's a linear relationship. This should be kind of make sense to you. Certainly you can have other kinds of things here. Instead of just x, you might have like x squared or a square root of x. So let's look at an example of that. Actually, a physical example from physics, Hooke's law, is an example of direct variation, right? Tension varies directly as the distance a spring is compressed or stretched out. Okay, so here is an example where direct variation has a little bit of a twist to it because we can vary directly as things other than just another variable. It can be like the square or the cube or something, or the square root of in this example. Okay, so how do we say this? Well, a is going to vary directly, so I need this k. As soon as I see vary, I'm going to write k, and then the square root of s. So this says if a is 28 when s is 49, find the constant of variation. So we want to find k. We could just go straight into plugging numbers in for a and s, or we can just solve for k. So k would be equal to a divided by the square root of s. Now plug in your a and k. So 28 divided by the square root of 49. 28 divided by 7, 4. Okay, so k would be 4. The constant of variation is 4. All right, now let's look at an application kind of problem here where it says r is directly proportional to t. When you see proportional, that means varies directly with, okay? So r is equal to k times t. That's what this is. Actually, I think I have that here. So r is equal to k times t. So it gives us a situation that r is 40 when t is 48, which means we would have r and we'd have t. We would just need to find k. So k would be equal to t divided r divided by t. So we're going to find k first. So r is 40 and t is 48. So this would be, what is this? 5/6, right? Now we want to find the value of r when t is 84. So r would be 5/6 times 84, which of course this is obviously some number that I can't think of right now. Give me a minute, I'll figure it out. It would be 14, right? So this is 5 times 14, so r would equal 70 here. I did math in my head. So r would be 70, okay? And that would just be an application style problem for direct variation. Okay, let's move on to inverse variation. If something varies inversely with another thing, that just means that as one thing goes up, the other goes down, or vice versa. As one goes down, the other goes up. Now, I want to draw a typical kind of graph of something like this. In fact, the graph of y equals 1 over x looks something like this. It looks like, I mean, this is a really rough sketch, but something like this. And if you had, for example, you were plugging in x values that were much larger, you would have y values that are getting smaller and smaller. Like, right, they're big. Y values are big when x is small, but then as we move to the right on x, the y values get smaller. And same thing here. If we get smaller and smaller x values, we're gonna get smaller. Yeah, that's right. We're gonna get smaller x values. We're gonna get bigger y values. Okay, like closer to 0, I mean, right? So this is what inverse variation looks like, kind of graphically. So these things should kind of make sense. Now, Boyle's law is an example from chemistry. Volume is inversely varies inversely as pressure for a gas. Here is an application problem. If m is inversely proportional to m, okay, inversely proportional again means varies inversely with as, or varies inversely with, or varies inversely to. M is equal to k divided by n. That's it, right? We see vary, we write k inversely, we're dividing, boom. So now we're given m and n, and we want to find k. So k would be equal to m times n. So k is equal to 6 times 15, which is 90. So k is 90. You could even check your work here, right? So m is 6 when 90 divided is like, is this true? Yes. So we know we did it right. Okay. Now let's move on to joint variation. False. Let's look at another inverse variation problem. The time traveled in a given distance varies inversely with the speed. Rate times time equals distance, right? And t is equal to distance divided by rate. So in this case, d would be the constant of variation, but we're going to use k. If it takes 4 hours at 70 miles per hour to travel that distance, how long would it take at 56 miles per hour? Okay, well, if it takes 4 hours at 70 miles per hour to travel that distance, that means that the distance was 280 miles, right? Okay, how long would it take at 56 miles per hour? I don't know, 280. So again, the time is equal to distance divided by rate. So 280 divided by my new speed of 56, that's some kind of number. It's gotta be 5, right? Is it 5? Yeah, it's 5. 5 hours. Easy. Okay. All right. Now let's move on to joint variation. So joint variation is when many things vary with another thing. So for example, volume varies jointly as h in the square of r. So this is like the volume, for example, maybe of like a cylinder, where in this case k would be pi, but that's not important. We have this multiple things together, joint together, okay? An example from nature might be that v varies jointly as t or inversely as p. You could even say this v varies directly as t and inversely as p. Just different ways to say kind of the same question. Let's look at an example of joint variation now. Suppose A varies jointly as B and C and inversely as D. Okay, so the first step would be to write out this equation. So A varies jointly. I heard vary, so I wrote K jointly. So B and C, but then inversely as D. So D in the denominator. There you go. Now it says if A is 2, B is 16, C is 7, and D is 28. If A is 2 when 16, 7, and 28 are the answers, well, I'm going to have A, B, C, and D. I would need K. So I could I could plug these right in right now, and we're going to find K. So 2 is equal to K, which you don't know, times B, which is 16, times C, which is 7, divided by 28. If I do a little factoring, this will be 4 times 7, this is 4 times 4, this is 7. I can just cancel out that 4 and that 4, and that 7 and that 7. So we'll have that 2 is equal to 4K, or that K is equal to 1/2. Now that I know that K is 1/2, I can look at the next part of the problem that says find A when B equals 10, C equals 9, and D equals 45. So A is equal to, I have my new value for K, which is 1/2, times B, which is 10, times C, which is 9, divided by D, which is 45. So that's just going to be 1. 1/2 times 10 is 5, times 9 is 45, divided by 45 is 1. So that's it. That's the end of the variation. Like it's a pretty straightforward idea. Really, the hardest part is probably translating into this kind of equation based on what's given to you in the problem. But if you see varies, you know you got to put k. If you see jointly, you're going to be multiplying some stuff, and then if you see inverse, you're going to be multiplying more than one thing. I mean, if you see jointly, and then inverse, you're going to be dividing. That's really it. And even if it was more basic, it would say varies directly as, you just straight up, it's y equals kx, or kx squared, or k times the square root of x, or whatever it says. All right, that's it.